Lab 26, example 3. We want to identify the degree, the leading coefficient, the zeros with multiplicities, and sketch the function. We have the function y is equal to x plus 6 squared times x minus 2 times x plus 3. So we're going to identify the degree. That's going to be represented by n. N is going to be the exponent of the largest x, or it's going to be the number of zeros. So if we count the number of zeros, we have x plus 6, and that's to the 2. So we have 2 zeros right here. We have 1 here and 1 here, so that's a total of 4. So our n is 4. Another way you could think of that is if we multiplied it all out for our very first term, we'd have x times x times x times x, and that means we'd have x to the 4th power. So our n is 4. Next, we want to find our leading coefficient a. This is going to be the number in front of our very first term, that x to the 4th power term. So again, if we multiplied it out, we have positive x times positive x times positive x times positive x. So our very first term, the number in front of it, is just going to be positive 1. And then next, we want to find the zeros with the multiplicities. So to do that, we're just going to set this y is equal to 0. So we have 0 is equal to x plus 6 squared times x minus 2 times x plus 3. This will remain true if either of these are 0. So if we set 0 is equal to x plus 6, then we get x is equal to negative 6. If we have 0 is equal to x minus 2, then we have x is equal to positive 2. And if we have 0 is equal to x plus 3, then we have x is equal to negative 3 if we solve that for it. And our multiplicities of x minus 6, this is going to be multiplicity 2 because we have 2 of this same 0. We have x plus 6 squared. For x is 2, this has 1 there, so this one is going to be 1. And for x is negative 3, this one is also going to be 1. So moving along, we want to sketch the function. So we have 3 zeros. We have negative 6, and we have negative 3, and we have positive 2. And we know that for a is 1 and our degree is even, we're going to go to our table over here. We have a is greater than 0 and we have an even degree, so it's going to be up on the left and right. So that means we're going to start from upwards and we're also going to end going upwards, like that. For negative 6, we have a multiplicity 2, so it's not going to pass through the x-axis, it's going to bounce off. Any even multiplicity, it bounces off the x-axis without touching it. And for the rest of the zeros, it's going to pass through the x-axis because our multiplicities are odd. They are 1 and 1, respectively. So starting up, and then we're going to go to x minus 6. And then because our multiplicity is even, we have to bounce off without passing through. And then we have to go to x is negative 3, or where our multiplicity is 1. So we know that we're going to have to come back down to negative 3, and we're going to have to pass through negative 3 because our multiplicity is odd. We're going to have to go to 2, and we're going to have to pass through since it is 1, which is odd. And so this is a quick sketch of what our graph will look like.